Good day to all. Welcome to this introductory talk on Virtual Labs project. The Virtual Labs project was conceived with two important things in mind. Any engineering educational institute, when it plans to start new experiments, it is faced with dilemma where to get the money for sophisticated equipment and also where to get faculty members who have the know-how of carrying out these experiments. So, the Virtual Labs project is an initiative of the Ministry of Human Resource Development MHRD under the National Mission on Education through Information Communication and Technology. The entire spectrum of virtual labs, they can be accessed from a single source web link www.vlab.co.in. The Virtual Labs project is possible because of the participation of 11 institutions, namely IIT Delhi, IIT Bombay, IIT Kanpur, IIT Kharagpur, College of Engineering Pune, IIT Roorkee, IIT Guwahati, IIIT Hyderabad, Amrita University, Diyalbag University and NIT Surathkal. The motivation behind the Virtual Labs project is that physical distances, they should not limit doing experiments for engineering students. Also, if a given engineering institution has costly equipment, we should have a mechanism by which the resources they can be shared. It also helps in proliferation of quality labs set up by premier institutions. The basic idea is that either a physical lab or a simulation engine is there in the server and this is accessible to users remotely. By remote users, we mean engineering college students. So, a virtual lab essentially comprises of a user friendly graphical front end which is available to the user, and at the back end we either have a simulation engine running on a server or an actual measurement data or a real experiment happening in the form of a physical lab. So, we have a single point window for all virtual labs www.vlab.co.in. Now, what were the objectives of the project when the project was conceived? The first and the foremost objective is to provide remote access to labs in various disciplines of science and engineering. Next, to cater to students both at UG and PG level. At the same time, we also tend to motivate research scholars. Next, to enable the students to learn the concepts at their own pace and at the same time to arouse their curiosity. Lastly, to provide a complete learning management system that includes web resources, video lectures, animated demonstrations and self-evaluation. The overall structure of the virtual labs is highly decentralized. When the idea was conceived, that time discipline wise national coordinators were chosen, and these discipline wise national coordinators, they invited proposals from lab developers. So, as the proposals were received, the labs they started setting up. So, it is a highly informal mechanism for setting up of the virtual labs. The ecosystem is highly flexible. We have nodal centers. Each nodal center has coordinators, both comprising of faculty members and students. And then we have the lab developers, which are assisted by project associates and field engineers. So, this flexible environment, it led to the development of a large number of different virtual labs. Now, we have certain target users in mind. The first target group is college students, especially those college students who do not have access to very good lab facilities. Now, the next target group is high school students who have somehow some inquisitiveness, but they do not have the facilities. So, we tend to motivate them so that they can take up higher studies in the fields of science and engineering. The next target group is research scholars in different premier institutions who can possibly collaborate and share equipment as well as expertise. And lastly, we have the engineering colleges in mind, which can benefit from both content and the teaching resources. We have covered mostly all broad areas of engineering and sciences, such as electronics and communication engineering, computer science and engineering, electrical engineering, mechanical engineering, civil engineering, chemical engineering, biomedical engineering and biotechnology, chemical sciences and physical sciences. So, most of the major areas of science and technology are covered. If you go through the virtual labs, you will find that there are three types of virtual labs. The first type is remotely triggered, where there is a physical lab. The next type is measurement based, where physical lab is not there, but we are storing the previously measured data in a server. And the third type is based on modeling and simulation. Let us see in detail. So, remote triggered lab means that the lab is physically existing at some institution, and from this central location the lab is accessible to the distant users through the internet. So, the lab gets converted into a virtual lab at the PC of the student, and the idea is that the student he should get the complete graphical user interface, which gives him the feeling that he is performing the experiment near live manner. The next category of lab is simulation lab. Now, here there is a simulation engine which runs on the server in the form of mathematical formulas, and this provides a graphical user interface to the end user. The third type of lab is very similar to simulation lab. The only difference is that rather than a simulation engine, we have experimental data which is available to the user at the front end. So, these three types of labs, they are together combined to make different kinds of virtual labs. Now, we have assessed the overall impact of the project. During the last few years, the virtual labs project has provided accessibility to quality labs. It has led to the development of novel processes. When we invited proposals for virtual labs, a lot of new innovative ideas came. Then this provided a platform for information and knowledge exchange, and this has also provided a very good application to the national knowledge network. We have done a lot of value addition. For example, now we have on demand labs where students they can learn at their own pace. We have the facility for integrated learning, where all the contents they are found at a single place. We have the facilities for self evaluation in the form of quiz, which the students they can take either before performing the experiments or after or both. And then we have the concepts taught by animations and video, which makes it easy for the students to learn. So, here unlike the conventional labs, students do not have to worry about committing mistakes. Here if student learns the concept, he is free to commit mistakes without any worry of his marks being deducted. Now, the first phase of the virtual labs project, it started in May 2009 and it continued until March 2014. The virtual labs they were dedicated to the nation on 23rd February 2012. The first phase was led by Professor Surendra Prasad, former director IIT Delhi as the PI, and Professor Ranjan Bose, electrical engineering department was the co-PI. Now, during the first phase, field trials were conducted in over 100 engineering colleges with more than 1000 faculty members and more than 1 lakh students trained in the virtual labs. A total of 36 workshops were conducted. Field trials they were done with several nodal centers identified, and each nodal center was responsible for dissemination of the lab to the colleges situated around it. So, the workshops they were widely conducted and they provided a forum for the dissemination of the virtual labs. trainings and both field trials they were conducted, and most of the virtual labs they have their brochures ready now. Now, we measured the success online and offline. Now, what we found that the students they are very eager to use our virtual labs beyond the office hours. Typically, we have found that the time between 2 p.m. and 4 p.m. that is the most widely used. The user statistics also show that Mondays and Tuesdays they are the most sort of time for the lab users. And we have also found that the hits they are varying at different hours of the time. Typically, during the midday we have the maximum number of hits and the pages. We have very meticulously gathered all the feedback both online and offline, and what we have found is that majority of the users they have rated the virtual lab experience to be either excellent or very good. We have done a very thorough quality assessment both in field trials as well as from the technical content point of view. From technical content point of view, we have done midterm evaluation by subject experts, and for field trials we have taken both online as well as offline teachers feedback, students feedback, and of course, the students who perform the experiments they have taken self evaluation also. All the feedbacks they have been communicated to the lab developer, and the good thing is that the lab developers they do corrections and improvement in a very continuous manner. Now, here as part of the phase 1, we found a number of challenges which we have thought over. The first is that the labs they were set up in an invitation basis, where we invited proposals, and some of the labs they are quite high end, and right now the labs or the content which is covered may not be part of the AICTE or UGC approved syllabus. So, our challenge is to do a mapping of the experiments, because the engineering syllabi is very diverse. So, we need some kind of standardization, so that we have some experiments they conform to AICTE and UGC. However, we need to enthuse the students, so that they are also motivated to perform experiments out of their routine syllabi. And we need to slowly introduce the virtual labs in the regular curriculum of the colleges. Now, backend support, we need discipline wise backend support, so that the process is a continuous process. Then scaling up, we need to replicate the experiments, and we need to do deployment of the simulation based labs, because simulation based labs they do not require much investment. Once they have been ready, they can be easily proliferated. The last and the most important aspect is training of the faculty members and the students. So, these process have to be made online. Now, all these points we have thought over to address in phase 2, which will commence from 2014 until 2017, and our slogan is outreach, integration and maintenance. These are the 3 key buzzwords for phase 2. Phase 2 will be led by Professor R. K. Shivgaonkar, Director, IIT Delhi, and he is supported by co-investigators Professor Ranjan Bose, Electrical Engineering Department, IIT Delhi, and myself, Suresh Bhalla, Civil Engineering Department, IIT Delhi. Now, the objectives in phase 2 are: number 1, to maintain upkeep the existing operational virtual labs; number 2, to port the virtual labs to a common platform and host on a national server; number 3, to create a single package of simulation based virtual labs for distribution; number 4, to engage professional agencies for outreach; number 5, to identify the gap areas between the typical syllabi of technical universities and the existing labs, and to develop additional labs or experiments to fill up the gaps; number 6, to convert the labs which are currently not based on free and open source technologies to open source; number 7, to port the existing labs to mobile platforms, because now tablets they are readily available to the students. So, possibly if the format of the experiments can be made compatible with tablets, then this could be a great help to engineering students. Lastly, number 8, we plan to identify and work with government, private agencies and professional bodies for granting some kind of certificate to the users of the virtual labs. So, as target, we are planning to have at least 110 simulation labs ready and more than 40 remote triggered or RT labs ready. So, we plan to have lots of nodal centers across the country and we will do integration of all the simulation labs. So, our target is that at the end of phase 2, we will have at least 21 lakh usages in among the engineering college students. Now, virtual labs has been created. The more the students use it, the more feedback they provide to us, the more improvement as lab developers we can do. Now, it is different from the regular book form reading. Here the concepts are learnt by doing. So, students they go through the manuals, read them and perform the experiments. Of course, here you do not have to worry about committing any kind of mistakes, because here you can learn at your own pace and you can at the same time commit mistakes, learn from them and again repeat and achieve your goal. So, we have great expectations from the virtual labs project, and after phase 2, rather during phase 2, we hope that it will be very popular among the students. So, thank you for your patient listening. If you have any feedback, please you can send it to us. Thank you very much.